Hey everybody, welcome back. In this video, we're going to look at how to calculate a 5-number summary using the calculator as well as a sample mean and the sample standard deviation. So I'm going to take this data set. I've actually already put it into a list in my calculator. I will show you how I did that. But we're going to take this data set from our Chapter 3 PowerPoint. We're going to input it into our calculator, and from that, we'll calculate all of those things. So let me pull up the TI-84 graphing calculator. And so to input that data, I'm going to hit this stat button. And then I'm going to either hit the number 1 or just hit enter. I want to select this first option, which is edit. And you can see that takes me to the screen of multiple lists. So we have L1, L2, that's list 1 and list 2. So you can see I've already input the data from the PowerPoint into list 1. But if this list was blank, you could just simply enter in the data, right? So that first data point is 29. So you just hit in 29 and enter. Hit 25 and enter, right? And you would work down the list, entering all of your data points one at a time, basically hitting enter along the way as you go until you have input all the data into the list. To get out of this screen, we're going to hit the second mode button, which is quit. So now that we have our data input into the calculator, we're going to go back to the stat button. We want to arrow over to the right to this calc tab. And then I want this option 1 again, this 1 var stats, which is short for 1 variable stats. So I'm going to hit enter or 1. And you can see it asks for you to input a list. Basically, we have L1 listed. If this was empty, or if you put your data into another list, you could select the list you want to calculate the sample mean and everything on by hitting second stat, which takes you to the list screen. You can see you can choose, right, list 1, list 2, list 3, and so on. Whichever column you inserted your data into on that previous screen, right, is the list number you would want to choose here. I put my data into L1, so I'm going to hit enter, and you can see that that now shows up here. So if we scroll down and hit enter on calculate, you can see where the first thing we're given is X bar, which is our sample mean. So this has calculated the sample mean for us. If you jump down to S of X, that is our sample standard deviation, it's 19.637. This sigma X is if these 25 data points in and of themselves were some sort of population, right? So maybe the 25 data points were the students in my class this semester, and I was treating you all as some sort of population, right? But in this class, when you're asked to calculate a standard deviation, it'll most likely be a sample. So we won't really worry about the sigma of X when we're calculating standard deviations. It'll most likely be a sample standard deviation. It gives us little n, which is our sample size. And that was equal to 25. We had 25 data points. And then right below that, these next 5 items are our 5-number summary, gives us the min, right? So the smallest value in our data set was 1. It gives us the Q1, the first quartile, which is 10. Gives us the median, which is our second quartile, and that is 20. Gives us our Q3, or our third quartile, which is 30, and it gives us our max, which is 80. So remember, from the 5-number summary, you can create a box and whisker plot. You can also determine upper and lower outliers, right? So to determine upper or lower outliers, we need our IQR. The formula for this is just Q3 minus Q1. And we're given both of those things, right, from our calculator. So Q3 is 30, Q1 is 10. So 30 minus 10 is 20, which is going to be our IQR. And then to find any lower outliers, we're going to use this formula. We're going to take Q1 and we're going to subtract 1.5 times our IQR. And this order here is actually very important. You wouldn't want to do this multiplication and then subtract the Q1. We need to make sure we keep it in this order. So our Q1 is 10, right? We'll see why the order is important here in a second. So we're going to take 10 and we're going to subtract 1.5 times our IQR, which we've already calculated, right, is 20. So 1.5 times 20 is equal to 30. And 10 minus 30, smaller number subtracted from a larger number, is negative 20, right? This is really important. We get a negative number here. So this is the cutoff for any lower outlier, basically. So if we have any number smaller than negative 20, then that number will be deemed an outlier. If we had switched these two things, we would have done 30 minus 10, right? A bigger number minus a smaller number. We would have gotten a positive 20 here. That would be incorrect, right? We have a lot of numbers less than positive 20, but those numbers are not lower outliers, right? So the order of this formula is very important. You need to make sure you take Q1, right? Subtract that from this, as opposed to calculating this first and then subtracting Q1, okay? So let's go back to our data. We don't have any negative numbers, right? So there are no lower outliers in our data set. And now let's calculate or see if we have any upper outliers, right? So the formula for the upper outlier cutoff is going to be Q3. This time we're going to add the 1.5 times the IQR. So Q3 is 30. We've already calculated this number in here, right? 1.5 times 20, which was our IQR, gave us 30. So 30 plus 30 is equal to 60. So if we have any numbers greater than 60, those will be considered upper outliers. So if we go back to our data, I believe there are 2 data points that were greater than 60, right? Nothing here in this first row, but we do have 80 and 66, right? These are both greater than 60. So these are both upper outliers.